Okay, so yeah, let's go to the demo. So keep calm, it's demo time. The demo will be around a polyglot application called Acme Fitness. The Acme Fitness app has different microservices with different roles. You can see the front end is the main page that we will hit as a customer, but in the back end we have carts, orders, catalog for the products, and user services. There's gonna be different use cases in the demo. So we're gonna start just by taking a look on the operational side. We're gonna onboard the cluster to Tanzu Service Mesh, and we're gonna see the onboarding process, and then we will go over some details with one of our development clusters. Now, the application itself has different constraints that needs to be splitted between two different clusters. So what we're gonna do is we're gonna install the front end of the application with a service called shopping in one cluster, and the backend services will run on a different cluster with all the other application services. Now that means that we have to have that global namespace construct that we've discussed to create a cross-cluster connectivity with all the benefits that we've said for a GNS, like DNS server, root CA for digital certificates and encryption, observability, and other things, and we will see that in the demo. Now, moving to the production and the DR environment, we're gonna go to the use case of some kind of unique capabilities from cloud. So the backend services must be installed on Azure, let's say, in our case. So the backend services will be on AKS, on Azure Kubernetes Services, but the front end, just for the resiliency sake, will be installed on one of them. The DR will be on the Tanzu Kubernetes Grid cluster, and the other one will be on AWS cluster. So we will have two different front ends on two different clouds, when the backend, both of them will be on AKS. And we're gonna group all the four inside the same global namespace. So we will basically have a full mesh between all the four clusters with one global load balancer referring to acme.tanzuworld.com, and you can try it right now. You can browse that. It's working. And if you want to get to a specific one of them, you can do either dr.acme.tanzuworld.com or prod.acme.tanzuworld.com. And those are the two endpoints that will be behind that global load balancer when everything is being managed by the global namespace of Tanzu Service Mesh. So that's the way that we will end our demo, where we will have like the full mesh between four different clusters, and we can start by just onboarding a cluster. Okay, so let's start by onboarding a cluster. On the left side, I have my Tanzu Service Mesh dashboard with a lot of different capabilities that we will go over in the demo. On the right side, I have a developer UI called Octant. Octant is an open source project that allows you to basically manage all of your Kubernetes cluster from a single point, taking a look on the application side of things, on the namespace construct, or the cluster side of things on the infrastructure construct. And if I will click on the right side of Octant above, you will see all the clusters that is being part of that demo that I'm recording right now. So basically what we're gonna do is, again, we're gonna onboard a cluster, and we're gonna onboard a VMware TKG3. TKG is Tanzu Kubernetes Grid 3. And when I'm going to cluster overview, you can see I don't have anything related into Istio on the cluster. So what I'm gonna do right now is I'm gonna onboard that. I'm gonna add new on Tanzu Service Mesh, a new cluster, and I will give it a name. So the name is VMworld TKG3. I'm gonna generate a security token, and now I'm gonna apply the security token on my console. So I will take my console for a second. You can see I'm in the context of demo VMworld TKG3. I'm copying the YAML file, applying that here. So now it's gonna create a lot of different objects it needs, and I'm also applying the token that will allow me to interact with our service. Now, if I'm going back to Octant, you will start seeing new namespaces and new constructs here, and you will see a lot of different events coming in the creation of everything related into the AllSpark or the Tanzu Service Mesh components. I'm just refreshing my screen. And you can see already there's a new namespace with the name AllSpark. You can see on the left side that the configuration of the management plane is being made right now. If I will click on the namespace, I can see the different application that runs as part of the AllSpark namespace. So you can see the AllSpark proxy and the renew of the token that I've created and the cluster manager. And now we're gonna get into the second phase of the installation of the data plane of Tanzu Service Mesh. So let's wait a couple of seconds, and because it's recorded, I can fast forward. Okay, so now we have the button of install Tanzu Service Mesh in the Tanzu Service Mesh console. And once I'm clicking the install, now it's gonna create a new namespace, the namespace of the Istio system, and it's gonna install all the components of Istio as the data plane for Tanzu Service Mesh. You can already see that it's being created right now. It's identifying the cluster type, and there's a lot of different steps in the installation. But what we can see right now is, if we will refresh the screen again, is that we have an Istio system namespace. There you go. If I will click on the Istio system, I can again see all the different application components that is installed as part of the Istio installation. That's all of the Istio installation. But the most important part is to go to services. And inside the services, we will see the Istio services that is being created as part of the installation. And again, the most important part here is the Istio Ingress Gateway. That's the IP which we will expose externally basically to our customers to consume the application. So right now I'm gonna fast forward to the end of the onboarding. Okay, so we finished the onboarding process, and we can see VMworld TKG 3 is on the dashboard. I can see 3 nodes, but nothing is running on that cluster because we haven't installed anything. I'm gonna take VMworld TKG 2, that is the development cluster, the one that runs the entire application without any change of the architecture. If I will click on that TKG 2 cluster, I can see the map of the connectivity. So I can see the shopping, that's the front end, and all the backend services that is connected. And I can see the Istio Ingress Gateway. That's the service that we've discussed. That's the basic Istio Ingress Gateway, just like here in TKG 3. And I want to browse that cluster, so I can go to my TKG 2 cluster and just take a look on the IP for the same Istio Ingress Gateway. So I will change to Istio system, and those are the services. So it's 12.12.98.100, and I already have a DNS suffix for that, so it's acmedev.tanzuworld.com. If I will refresh the screen, I will see that the site or the application is a whole. So I can see the pictures, I can go to catalog, and I will see the catalog items. I can go to contacts, and I can even browse some products that I have inside the catalog. Now that's an entire application running, so we can see that here. And if I will click on one of the services, I can see the connectivity of the backend services. I can see the map that is being created for service discoverability. I can hover above one of them and get a golden matrix. So what's the request wait? What's the P99 latency? If there's any errors. And there's a lot of different operational perspective that I can see. So CPU usage, where it's installed, what's the node health for that cluster. So there's a lot of different options that I can see just from onboarding a cluster and running my application on top of that. But now we want to leverage, the cross cluster, not just one cluster. There's a lot of operational benefits just running one cluster. And as part of Tanzu Service Mesh, you will also have the support for the data plane, for in this case Istio, and you will have a lifecycle management for that. So that's great for one cluster. But we are more looking for, the abstraction of the networking, just like we said in the presentation. So let's connect the dots between the front end and the back end by leveraging more than one cluster. So in this case, I have 2 different clusters here. So I have the front end cluster, Acme front end cluster, and the Acme back end cluster. You can see the front end is running only shopping, and the back end is running multiple services that is not connected into anything. That cluster is what I call a dev splitted one. So it's just like TKG2, but I'm splitting between the front end and back end. If I will go and try to browse that right now, the Acme splitted.tanzuworld.com, I can see that I have the home page, But if I would go to catalog, I won't see anything. So there's no connectivity between the clusters, and what I'm browsing right now is basically just the shopping on the front end. If I will go to Octant and change the cluster into Acme frontend, you will see the configuration of the Acme app on that front-end cluster. So I can go to applications, and I'm expecting to see only shopping. That's only the front end. I can see the consumption rate and everything else. And if I will go to namespace overview, I can actually see the deployment. Why it's important? Because one of the connectivity things that we need to do is we need to say in the front end how to get to the back end. Now, the way to do that is just by changing the service to service reference. So I need to basically refer into a different service that basically doesn't exist in my cluster. So if I will go to deployment of the shopping and I will go to YAML, I can see the declaration of the object. And if I will go down on that YAML file, I can see how it's referring to the backend services. So it's referring to carts.dev.acme, catalog.dev.acme, orders.dev.acme, and so on. So users.dev.acme. Now that .dev.acme is not a DNS record that I have externally, and that cluster doesn't know anything about it. But that's exactly how we're going to connect between the two clusters. So what we're going to do is basically we're going to create a new global namespace. That global namespace will be the dev acme global namespace, and the domain will be the suffix that we've created on the deployment itself. So the domain will be dev.acme. When I'm doing next, now I need to choose basically the clusters that I want to be part of that namespace, global namespace. So I'm going to take front end and I will do Acme. I can see in service preview that I have only shopping in the front end. And if I will do the same for the back end, you will see all the services in the back end. I'm going to do next. I'm not going to add any public services right now, not external services, but I am going to enforce mutual TLS encryption. So it's going to encrypt everything between service to service, in cluster and cross cluster connectivity. And that's it. I'm going to do finish. Now that creation of global namespace will inject to my cluster different objects that will allow that cross-cluster connectivity. Those objects are part of the custom resource definition capabilities of Kubernetes. So it's basically introducing new objects that refers into different things. So if I will go to custom resource definitions in my Acme namespace, I can see service entries. Service entries are DNS records from GNS that basically allows you to refer to other services that it's not in your own cluster. So you can see the DNS entries of carts redis, catalog, orders, and so on and so forth for services that it's not really installed in your cluster. Same goes for virtual services. If you know Istio, if you install Istio or play around with it, virtual service is the way that you're addressing or referring or routing traffic into a specific service. Those virtual services of NSXSM, GNS, something are virtual services that is referring into a different cluster, not this cluster. And that's important because now that we have that cross-cluster connectivity with the DNS, we can now go and try to browse the same application again, the Acme splitted TanzuWorld .com. And when I'm doing refresh, you can see that now I have pictures. And if I will go to catalog, I will have my catalog entries. And if I will click on one of them, I can get into the product. And if I will go to contact, I will see the contact. All of those different things are in a second cluster. That's in the backend cluster. And if I will go to Octant again and change for the backend cluster, you will see now in the Acme namespace that I have all the backend services, all the backend applications. So you can see here a lot of different applications running in the Acme backend on the Acme namespace. And the connectivity is being created between the clusters. How can you see that in Tanzu Service Mesh? We can go to the global namespace and we will see here the new global namespace. If I will click on that, you will see now that I have some kind of ingress controller, the front-end backend, and the backend cluster. So the front-end cluster, ingress gateway, shopping, and it's going through the ingress of the Acme frontend to the ingress of the Acme backend. But the connectivity is full, and you can see the same map that we saw on Tanzu Kubernetes Grid two cluster, but it's split between two different ones. And that's part of our, global namespace capabilities. And that's the way that we are creating that connectivity. Now, to keep going with the capabilities and presentation of the demo, I want to do something else. I want to basically now apply a security policy that is context-based. It's layer 7 security policy on that cluster. So I want to basically deny the traffic between the shopping and the backend services. I want to deny the traffic between the front end and the backend, and I want to do that for any kind of application transaction. So get, post, anything that will go between those two clusters. So what I'm gonna do now is I'm gonna go and get into the security aspects of things. I'm inside that global namespace for the front end and back end, and I'm gonna do security posture. Security posture allows me to see right now the flow between the front end and the back end cluster, and you can see it's allow all. If I will click on that Acme policy and I will edit that, I will see that the Acme policy is referring to the Acme splitted global namespace. It's the from Acme frontend to Acme backend. It's allowing everything right now, and there's no conditions. What I want to do basically is change that to deny. So I'm gonna change deny for everything. I'm gonna do next, no additional actions right now, and I'm gonna do save. That will basically deny the access between the front end and the back end. And if I will go now to my cluster again, and that's a splitted one, I will refresh the screen and it's not gonna work. So it's basically denying the traffic between the front end and the back end clusters according to that security policy that we've just created. So that's creating a security policy on layer 7, and that's gonna break the connectivity between those two different clusters just because of the security policy. Yeah, so that's as security, and I want to go to our DR and production demo and move along with the demo to a more complex situation. I'm just gonna go back and refresh the memory about the use case that we are doing right now. We have 4 different clusters. 2 of them are running the front end, one on AWS, the second on TKG. And we have 2 different backends running on AKS because we want to leverage unique capabilities from that cloud. One of them is dr.acme.tanzuworld.com, and if I will refresh that, I can already see that I have the cross-cluster connectivity because I have the front end and the pictures and everything else. And the second one is prod.acme.tanzuworld.com, and I can already see I have something wrong with that cluster. So if I will refresh that, I can see I don't have any cross-cluster connectivity. If I will browse the acme.tanzuworld.com, I can see that everything is being diverted right now to the DR because the production isn't working right and the health state is not working right. So let's try to troubleshoot that. If I will go now to my global namespace and I can get into my 4 clusters, that's the full mesh between the clusters. So what you can see here is basically 4 different clusters connected to each other with a full mesh. So the AWS is connected to both and the TKG is connected to both. And I can already see there's something wrong because if I will go to the catalog here, I can see it's connected only onto one cluster. It's not connected to my AWS cluster, and that's my prod cluster. And I can go again here and I can see the same thing. So something is off with the configuration of that AWS 1 cluster. And now I can do exactly what we did with the Acme frontend and backend. We're gonna troubleshoot that with Octane. So I will go to AWS 1 and I'm gonna go to Acme namespace. Let's go to workloads inside AWS 1 Acme, shopping, and same goes to as before. We need to check the connectivity between the different clusters. So I'm gonna go to the YAML and I can see that I have some kind of problem here because everything is demo.local, but the catalog doesn't have that service, that suffix. So I'm just gonna add that suffix and I'm gonna update the YAML file from the Octane UI. So if I will go back now to the workloads, you can see it's basically recreating the pods, recreating the YAML file and the deployment. And now when it's going to be up, it's going to refer to the backend service and the connectivity will be back. In the meantime, when it's going to be refreshed and the connectivity will be back and normal, let's go over two more capabilities that is important to go over. One of them is progressive upgrade. Progressive upgrade will allow you to basically roll your upgrade between different clusters, even if it's different clusters on different clouds. So you can go to deployments, and I can now say that I want to upgrade my Acme deployment. I want to upgrade that from version 3 to version 4. I can also drop a YAML file or something like that. I want to do 100% of upgrade. I want to do that with 10 steps, and I want to wait 30 minutes between step and step just to be able to ensure that everything is okay. So use default services to autoscale. How do I want to roll back? And of course, I'm not going to do that right now because I don't want to roll the upgrade, but that's going to create a rolling upgrade between the version 3 and 4 in my case, or in this case, between 3.05 and another version. And I can also do a version test. So I can, test the version, see the latency, understand the errors rate, and then decide if I want to keep going with that or not. Another capability that is important, and it's crucial, especially for that DevOps side of things, is the API Explorer. Everything that we see here in the UI can be achieved by an API call as well. So let's take an example. I'm gonna just query for the ID members of a GNS, and I can try it out directly from my console. So the only thing that I need to do is to say that I want to query for the members on the Acme namespace, and I'm gonna do execute. That's gonna run, and that's the command that it's running. So it's basically a curl. And now you can see the response. So the response has all the users, user Mongo, payments, all the services that is part of that GNS. And with that API Explorer, you can also create global namespace. You can change global namespace. You can create additional service groups or anything else. And that will allow you to, interact automatically with that console via API calls. So just to wrap it up, you can see the console with all the clusters. You can see the front-end cluster and the back-end cluster are divided. That's because we enforced a security policy that says that the front-end shopping service can get into the backend services, and that's why there's no connectivity. The second thing we saw is that we had some kind of trouble with the connection between the shopping and the catalog, and we've changed the YAML file of the shopping to refer to the right suffix of the GNS. So now you can see the catalog is connected into the two clusters, and you can see a full mesh between those 4 different clusters. What means that if I will go and browse the application right now of the prod.acme.tanzuworld.com, I would see the cross-cluster connectivity, and I will have my connectivity to the catalog and the backend services in the prod cluster as well, so in the AWS. And of course, in the DR, the connection will be the same. And now I have my global load balancer of acme.tanzuworld.com refers into those 2 sites, dividing the traffic according to whatever I will decide in that global namespace. So yeah, that was the demo. I hope it was useful. We've been over the onboarding process. We've been over one cluster connectivity and management with the observability aspects. We've been over the splitting application between different clusters, create the global namespace with the construct of DNS, encryption, and observability across multiple clusters. And we finished with just the use case of the production application where you have a production and DR sites connected into 2 different backend clusters. So you have like a full mesh of Acme Fitness between everything else. I want to thank you for the time, and I hope it was useful.